In this lecture we'll find out the length of line segment X. In the drawing we have two quarter circles. Those two quarter circles touch each other here at point B. In addition, you know that line segment AB equals to 1 unit in its length. QS equals to SP. And our mission is to find out the length of this line segment BC that is equal to X. To find out the value of X. So, first of all, because of the fact that this is a quarter circle, it means that AB and AP are equal to each other. They are both the radii of this quarter circle, therefore they are equal to each other. So, but AB equals to 1, therefore PA will be also equal to 1. Likewise, in the big quarter circle, BC and QC, they are both the radii of this big quarter circle, and therefore they are equal to each other. But BC is X, therefore QC must be also equal to X. In addition, those two angles, they are both right angles, and it is true in any quarter circle. This angle will be always a right angle in any quarter circle. In the next step, we'll join points P and B together by a straight line. And we'll join points Q and B together by a straight line. By joining points P and B, we created the right triangle PAB. So we copy this right triangle PAB in a new page, and we will implement the Pythagoras theorem in this right triangle PAB. Here by PT is abbreviation for Pythagoras theorem. So actually, this is the right triangle PAB that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle PAB, PB square equals to PA square plus AB square. PB square, that is the square of the hypotenuse, equals to PA square plus AB square. So PB square equals to PA square. PA is 1, therefore PA square is 1 square, that is 1, plus AB square. AB is 1, therefore AB square is 1 square, that is 1. So in total PB square equals to 1 plus 1, that is 2. So here we will take a root out of this equation, and we get that PB equals to the square root of 2. The hypotenuse PB equals to the square root of 2 units in its length. So I can write down in the original drawing that the hypotenuse PB of the right triangle PAB is equals to the square root of 2 units in its length. Likewise, we repeat on the same process on the right triangle QCB. So I copy the right triangle QCB in a new page, and we implement the Pythagoras theorem in this right triangle QCB. Again, by PT is abbreviation for Pythagoras theorem. Actually, this is the right triangle QCB that I call it from the original drawing. In this right triangle QCB, QB squared equals to QC squared plus BC squared. So QB squared, that is the square of the hypotenuse, equals to QC squared. QC is x, therefore QC squared is x squared plus BC squared. BC is also x, therefore BC squared is x squared. So in total, QB squared equals to x squared plus x squared, that is 2x squared. Here we take a root out of this equation and we get that QB equals to the square root of 2 times x squared. That is to say, QB equals to the square root of 2 times the square root of x squared is x. So in total, QB equals to the square root of 2 times x units in its length. So we can write down here in the original drawing that the hypotenuse QB of the right triangle QCB is equals to the square root of 2 times x units in its length. In the right triangle PAB, side PA equals to side AB. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides, you have those two angles that must be also equal to each other. So if we define this angle as alpha, then the other angle must be also equal to alpha because they are equal to each other. Okay, and we know that the sum of the angles in any triangle is equal to 180 degrees. Therefore, in triangle PAB, which angles we have in triangle PAB? We have alpha plus alpha, that is 2 alpha, plus this is the right angle, it is equal to 90 degrees. In total, the sum of those three angles must be equal to 180 degrees. So repeat again, the sum of the angles in the right triangle PAB must be equal to 180 degrees, that is to say 2 alpha plus 90 degrees equals to 180 degrees. Here we subtract 90 degrees from this equation and we get that 2 alpha equals to 180 degrees minus 90 degrees is 90 degrees. 2 alpha equals to 90 degrees. We divide this equation by 2 and finally we will get that alpha equals to 90 degrees over 2 is 45 degrees. So this is angle alpha is equal to 45 degrees in its size. And this is also angle alpha that is equal to 45 degrees. If we repeat on the same process on the right triangle UCB, we arrive to the conclusion that those two angles also equals to each of them is equal to 45 degrees. So this angle equals to 45 degrees and this angle also equals to 45 degrees. In the next step, I present to you a new rule, rule number 3, and we'll implement rule number 3 in our drawing. Our drawing here, according to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So in the drawing we have this straight line AB. If we focus on the upper side of the straight line AB at point Q here, the sum of the angles must be equal to 180 degrees according to this rule, rule number 3. So which angles we have and the upper side of AB at point Q, we have this angle alpha and the other angle beta. So alpha plus beta must be equal to 180 degrees according to this rule number 3. Actually, we can implement rule number 3 in our drawing. Why? Because in our drawing, if you focus on the upper side of this straight line AC at point B, again, we focus on the upper side of this straight line AC at point B. Here the sum of the angles must be equal to 180 degrees according to rule number 3. So we can guess we have at the upper side of AC at point B. First of all, I will copy the straight line AC with point B in a new page and we'll implement rule number 3 in the straight line AC. So actually, this is the straight line AC that I copied from the original drawing. So we can guess we have at the upper side of the straight line AC at point B, we have this angle that is equal to 45 degrees, plus the missing angle that we will define as x, plus this angle that is also equal to 45 degrees in size. In total, the sum of those three angles must be equal to 180 degrees according to rule number 3. So 45 degrees plus 45 degrees is 90 degrees. So in this side of the equation we have in total 90 degrees plus x equals to 180 degrees. Here we subtract 90 degrees from the equation. And we get that x equals, the missing angle x equals to 180 degrees minus 90 degrees is 90 degrees. Okay, so the missing angle here equals to 90 degrees in size. You can write down in the original drawing, this is the missing angle, it is the right angle. And therefore, triangle PBQ is a right triangle. Okay, so in the next step, I will copy the right triangle QBP in a new page and we will block this right triangle QBP. We have the rule that any triangle can be blocked by a circle, and therefore we can block definitely this right triangle QBP by a circle. So actually, this is the right triangle QBP that I copied from the original drawing, and I block this right triangle QBP by this circle. So actually in the drawing we have peripheral angle PBQ. This peripheral angle PBQ is equal to 90 degrees in its size. So write it down. Peripheral angle PBQ equals to 90 degrees. It is a right angle. And we have rule number 5 that relates to any peripheral angle that is equal to 90 degrees in its size. So according to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. So we have here a circle. Inside this circle we have peripheral angle MAN. This peripheral angle MAN is a right angle. It is equal to 90 degrees. Therefore, this peripheral angle MAN must be subtended on the diameter of the circle. So repeat again, because of the fact that peripheral angle MAN is equal to 90 degrees, it is a right angle. This peripheral angle MAN must be subtended on the diameter of the circle. And indeed, MN is the diameter of the circle. Why? Because MN passes through point O, that is the center of the circle, and any chord that is passes through the center of the circle must be the diameter of the circle. So in conclusion, you can say that because of the fact that peripheral angle MAN is a right angle, therefore it is subtended on the diameter of the circle. It must be subtended on the diameter of the circle. You can see here that peripheral angle MAN is subtended on MN, on the chord MN, that is the diameter of the circle. So you can actually implement rule number 5 in our drawing. Why? Because in our drawing we have this peripheral angle QBP or PBQ that is equal to 90 degrees. It is a right angle. Therefore, this peripheral angle is subtended on the diameter of the circle. That is to say, according to rule number 5, PQ is the diameter of the circle. Any peripheral angle that is equal to 90 degrees must be subtended on the diameter of the circle. Because of the fact that peripheral angle PBQ equals to 90 degrees, therefore it is subtended on the diameter of the circle. That is to say, PQ is the diameter of the circle. If we define the radius of this circle as R, then the diameter PQ must be equal to 2R. Okay. So PQ equals to 2R. It is the diameter of the circle. From one side, but from the other side, we have in the drawing line segment PQ. It is given us the question that PS equals to QS. So if we define PS as X, then QS or SQ must be also equal to X because they are equal to each other. Okay, so in the next step I will copy this point S that is located on PQ to our new drawing here. So this is point S, so I copied point S that is located on PQ from the original drawing to our new drawing here. Okay. So what is the length of PQ, on flying segment PQ. PQ equals to PS plus SQ. That is to say PQ equals to PS, that is X, plus SQ, that is also X. So in total, PQ equals to X plus X, that is 2X. So from one side, PQ equals to 2X. From the other side, PQ is the diameter of the circle, therefore it is equals to 2R. From those two equations, PQ equals to 2R and PQ equals to 2X, we derive that 2R equals to 2X. R equals to 2X. So we divide this equation by 2 and finally get that R equals to X. The radius of this circle R equals to X. So we can write here that X equals to R, and here also X equals to R. That is to say PS equals to R. So here PS equals to R, it is the radius of this circle, and SQ also equals to R. SQ equals to R. PS equals to R. So it is the radius that starts from point P and ends at point S. QS also equals to R. It is the radius of this circle that starts from point Q and ends at point S. So at point S, the two radii touch each other, and therefore point S must be the center of this circle. So I write it down. Point S is the center of the circle. Repeat again. This point S is the center of the circle. In the next step, we'll join points S and B together by a straight line. Point S is the center of the circle, point B is the point of the circle itself, therefore SB is the radius of the circle, that is equal to R. In conclusion, we found out that PS equals to SQ equals to SB. They are all the radii of this circle, therefore they are equal to each other. So you will join points S and B here in the original drawing. SB is the radius of the previous circle, that is equal to R. So in conclusion, we found out that SB equals to SQ equals to SP. Again, they are all the radii of the previous circle, therefore they are equal to each other. And especially we found out that SB equals to SQ. Okay, so in the next step, I will copy the big quarter circle to a new page, and then we will extend this quarter circle to a circle. Okay. So actually, this is the quarter circle that I got it from the original drawing. Again here, this angle equals to 90 degrees. It is drawn in any quarter circle. And we found out that SB equals to SQ. They are both the radii of the previous circle, therefore they are equal to each other. So in the next step, we will complete this quarter circle to a circle. So I completed this quarter circle to a circle. In the next step, I present to you a new rule, and we will implement the new rule in our drawing. Okay. The new rule is rule number 13. According to rule number 13, a central angle is twice as large as the peripheral angle subtended on the same arc. So in the drawing we have this circle. Inside this circle we have peripheral angle ACB. This peripheral angle ACB equals to theta in its size, and it is subtended on arc AB. In addition, we have in this drawing central angle AOB. This is the central angle AOB, and it is also subtended on arc AB. So in this drawing we have a central angle and a peripheral angle that are subtended on the same arc AB, and therefore the central angle will be twice as large as the peripheral angle that is subtended on the same arc AB. And because of the fact that the peripheral angle ACB equals to theta, then the central angle that is subtended on the same arc AB will be equal to 2 theta. Okay, so actually we can implement rule number 13 in our drawing. Why? Because in our drawing we have this is peripheral angle PSQ. This peripheral angle BSQ is subtended on arc QB, and we have the central angle QCB. This is actually the central angle QCB, and the central angle QCB is subtended on the same arc QB. Therefore, according to rule number 13, the central angle QCB will be twice as large as the peripheral angle QSB that is subtended on the same arc QB. Okay, now we have to find out what is the size of the central angle QCB, the size of this angle. In order to find out the size of this central angle QCB, we present to you a new rule, and we will implement the new rule in our drawing. The new rule is rule number 6. According to rule number 6, the sum of the angles around the point will always end up to 360 degrees. So in the drawing we have this point A, and according to this rule number 6, the sum of the angles around point A are equal to 360 degrees. In order to prove that rule number 6 is true, I draw this straight line that passes through point A. Again, this straight line is passes through point A. Now we can implement here rule number 3. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. That is to say, the sum of the angles in the upper side of this straight line at point A is equal to 180 degrees. Likewise, the sum of the angles in the lower side of this straight line at point A will be also equal to 180 degrees according to the sum rule, rule number 3. So in total, the sum of the angles in the upper side at point of this straight line at point A, that is 180 degrees, plus the sum of the angles in the lower side of this straight line at point A, that is also 180 degrees, will be equal to 360 degrees, exactly according to this rule, rule number 6, that states that the sum of the angles around point A must be equal to 360 degrees. Actually, we can implement rule number 6 in our drawing. In our drawing, we have, if we focus at this point C, according to rule number 6, the sum of the angles around point C must be equal to 360 degrees. So which angles we have around point C? We have this angle that is the right angle plus the missing angle. In total, the sum of these two angles must be equal to 360 degrees according to rule number 6. Therefore, the missing angle here must be equal to 270 degrees in its size. Why? Because 270 degrees plus 90 degrees equals to 360 degrees. That is the sum of the angles around any point and especially around point C. So the missing angle equals to 270 degrees in its size. The missing angle, it is actually the central angle QCB. So if the central angle QCB equals to 270 degrees, according to rule number 13, the peripheral angle QSB that is subtended on the same arc BQ will be equal to half of it. That is to say, it will be equal to 270 degrees over 2, that is 135 degrees. Okay. So, in the next step, we will focus on triangle SBQ. Triangle SBQ is an isosceles triangle. Why? Because side SB equals to side SQ. And we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be also equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha because they are equal to each other. And we also know that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have in the isosceles triangle QSB? We have alpha plus alpha, that is 2 alpha, plus this angle that is 135 degrees. In total, they must be equal to 180 degrees according to the rule that I mentioned. Here we subtract 135 degrees from the equation, and finally we get that 2 alpha equals to 180 degrees minus 135 degrees is 45 degrees. So 2 alpha equals to 45 degrees. We divide this equation by 2, and finally we will get that alpha equals to 45 over 2 degrees. So actually this is angle alpha that is equal to 45 over 2 degrees, and this is also angle alpha that is equal to 45 over 2 degrees in its size. So here, this angle is angle SQB that is equal to 45 over 2 degrees. So in the next step, I will copy the right triangle PBQ to a new page, and we will analyze this right triangle PBQ. the right triangle PBQ, side PB equals to the square root of 2 units. Side QB equals to the square root of 2 times x units. And this is angle alpha. This is actually angle SQB. Here. Angle SQB equals to alpha, and alpha equals to 45 over 2 degrees. So this is angle alpha. This is equal to 45 over 2 degrees in its size. And then actually this is angle alpha. This is equal to 45 over 2 degrees in its size. So in the right triangle PBQ, tangents 45 over 2 degrees equals to PB over BQ. Again, tangents 45 over 2 degrees equals to PB over BQ. PB is square root of 2 and BQ is square root of 2 times x. So here we have square root of 2 in the numerator and square root of 2 in the denominator, so square root of 2 will get cancelled, and we're left only with 1 over x. In conclusion, found out that according to equation number 1, tangents 45 over 2 degrees equals to 1 over x. Repeat again, according to equation number 1, we found out that tangents 45 over 2 degrees equals to 1 over x. I remind you that x is the line segment that we are looking for, and we have the trigonometric identity, the tangents 2 theta equals to 2 times tangents theta over 1 minus tangents square theta. So again, tangents 2 theta equals to 2 tangents theta over 1 minus tangents square theta. We will define theta as 45 over 2 degrees. If theta is 45 over 2 degrees, it means that 2 theta is 45 degrees. In the next step, we'll substitute theta in this trigonometric identity by 45 over 2 degrees, and we substitute 2 theta by 45 degrees. And we get that according to this trigonometric identity, tangents 2 theta, and 2 theta is 45 degrees according to our definition, is equals to 2 times tangents theta, and theta is 45 over 2 degrees according to our definition, over 1 minus tangents square theta, and theta is 45 over 2 degrees according to our definition. So in conclusion, we found out that according to equation number 2, tangents 45 degrees equals to 2 times tangents 45 over 2 degrees over 1 minus tangents square 45 over 2 degrees. In the next step, we will define tangents 45 over 2 degrees as t. I repeat again. According to our definition, tangents 45 over 2 degrees equals to t, and then we substitute tangent 45 over 2 degrees in this equation number 2, by t. And we get that according to equation number 2, tangent 45 degrees is 1, and it is equals to 2 times tangent 45 over 2 degrees is t, according to our definition, so we substitute it by t. So in the numerator we will have 2t over 1 minus tangent square 45 over 2 degrees. If tangent 45 over 2 degrees is t, then tangent square 45 over 2 degrees will be equal to t square. So this expression equals to t square. So in total, in the denominator we have 1 minus t square. So in conclusion, we found out that according to equation number 2, one equals to 2t over 1 minus t square. Here we multiply this equation number 2 by 1 minus t square, and we get that according to equation number 2, 1 minus t square equals to 2t. Here we relate to this equation number 2t square, and you get that according to equation number 2, t square plus 2t equals to 1. Here we subtract 1 from this equation number 2, and finally we get that according to equation number 2, t square plus 2t minus 1 equals to 0. So actually this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Okay. In our specific quadratic equation, t squared plus 2t minus 1 equals to 0, the variable that we are looking for is t, so x equals to t, the coefficient a equals to 1, the coefficient b equals to 2, and finally the coefficient c equals to minus 1. So the next step, we put the data inside the formula for x in order to find out the value of t. Why? Because x equals to t. So here x equals to t, therefore we substitute x by t. We are looking for the variable t in our quadratic equation, so x equals to t, so t equals to minus b. b is 2, therefore minus b is minus 2, plus minus square root of b squared. b is 2, therefore b squared is 2 squared, that is 4, minus 4 times a is 1, times c, that is minus 1, all divided by 2 times a. a is 1, so it is 2 times 1. So actually we found out that t equals to minus 2 plus minus. Inside the root we have minus 4 times minus 1 is 4, and 4 plus 4 is 8. So we left only with 8 inside the root, divided by 2. In conclusion, we found out that t equals to minus 2 plus minus square root of 2 over 2. So t equals to minus 2 plus minus square root of 8. 8 is 4 times 2, so we substitute 8 by 4 times 2 over 2. So t equals to minus 2 plus minus. The square root of 4 is 2, so inside the root we left only with 2 divided by 2. So t equals to minus 2 over 2 is minus 1 plus minus 2 over 2 is 1, so in total this expression equals to square root of 2. In conclusion, we found out that t equals to minus 1 plus minus square root of 2. So here we will have two solutions that are possible for t. The first solution for t is that t equals to minus 1 minus square root of 2, and the second solution that is possible for t is that t equals to minus 1 plus square root of 2. According to the first solution, t equals to minus 1 minus square root of 2. Minus 1 minus square root of 2 is a negative number, therefore t is a negative number from one side, but from the other side, according to our definition, t equals to tangents 45 over 2 degrees. That is a positive number, so t is a positive number. We have here a contradiction because t cannot be simultaneously a negative number and a positive number. And due to this contradiction, we cancel the solution, this incorrect solution, and we left only with the second solution that is possible for t, that t equals to minus 1 plus square root of 2. Or t equals to square root of 2 minus 1 from one side, but from the other side, we have only found out that t equals to tangents 45 over 2 degrees. So, again, t equals to tangents 45 over 2 degrees from one side, but from the other side, according to the second solution, t also equals to the square root of 2 minus 1. So in conclusion, we found out that according to equation number 2, tangents 45 over 2 degrees equals to the square root of 2 minus 1. That is from one side, but from the other side, we have already found out that tangents 45 over 2 degrees equals to 1 over x. Here we have on page 5, we already found out that tangents 45 over 2 degrees equals to 1 over x. So actually you have two different expressions for the value of tangents 45 over 2 degrees, two different equations. Therefore, we'll get the equation number 3. According to equation number 3, tangents 45 over 2 degrees, according to equation number 1, must be equal to tangents 45 over 2 degrees, according to equation number 2. Repeat again equation number 3. According to equation number 3, tangent 45 over 2 degrees according to equation number 1 must be equal to tangent 45 over 2 degrees according to equation number 2. So tangent 45 over 2 degrees according to equation number 1 is 1 over x, and it must be equal to tangent 45 over 2 degrees according to equation number 2. It is actually square root of 2 minus 1. If we're going to find out that according to equation number 3, 1 over x equals to the square root of 2 minus 1. Here we'll multiply this equation number 3 by x. And again, that according to equation number 3, 1 equals to the square root of 2 minus 1 times x. Here we divide this equation number 3 by square root of 2 minus 1. And we get that according to equation number 3, x equals to 1 over square root of 2 minus 1. So x equals to 1 over square root of 2 minus 1. So we'll focus on this side of the equation. And we'll multiply this side of the equation by square root of 2 plus 1, and then we'll divide it by square root of 2 plus 1. Square root of 2 plus 1 over square root of 2 plus 1 is 1. And it is allowable to multiply anything by 1. Therefore, this operation is allowable. And we find out that x equals to, in the numerator, square root of 2 plus 1 over square root of 2 minus 1 times square root of 2 plus 1. Here we have the algebraic identity that a minus b times a plus b equals to a squared minus b squared. So according to this algebraic identity, we get that square root of 2 minus 1 times square root of 2 plus 1 equals to the square root of 2 squared, that is 2, minus 1 squared, that is 1. So in total, this expression equals to 2 minus 1, that is 1. So if I found out that x equals to the square root of 2 plus 1 over 2 minus 1 is 1. So it is square root of 2 plus 1 over 1, and square root of 2 plus 1 over 1 is square root of 2 plus 1. That is to say, we found out actually that x equals to either square root of 2 plus 1 units in itself, or in terms of numbers, it is equals to 2.414 units. Repeat again, we found out that x line segment BC is equal to x. It is equals to either square root of 2 plus 1 units, or in terms of numbers, x that is BC, it is equals to 2.414 units. Okay, so in the next step, I will summarize the lecture. In this lecture, we found out the length of this line segment PC, is equal to x. In the domain, we have two quarter circles that touch each other at point B. In addition, we know that line segment AB equals to 1 unit in its length, and also we know that QS equals to SP. Our mission is to find out the length of this line segment BC that is equal to X. So, first of all, because of the fact that this is a quarter circle, here, PA must be equal to AB, they are both the radii of this quarter circle, therefore they are equal to each other. But AB equals to 1, therefore PA must be also equal to 1. So PA equals to 1. Likewise, in the big quarter circle, this big quarter circle, BC and QC, they are both the radii of this quarter circle, therefore they are equal to each other. But BC is equals to X, therefore QC must be also equal to X. Then we join points B and B, and we join points Q and B by a straight line. And then I copied the right triangle Q and B in a new page, and we implemented the Pythagoras theorem in this right triangle Q and B. Triangle PAB. This is the right triangle PAB that I copied from the original drawing. According to the Pythagoras theorem, PB square equals to PA square plus AB square. So PB square equals to PA square, that is 1, plus BB square. PB square, that is also 1. PB square is 2. We took out of this equation and finally found out that PB equals to the square root of 2 units in its length. Therefore, PB equals to the square root of 2 units. Then I copied the right triangle QCB in a new page and implemented the Pythagoras theorem in this right triangle QCB. This is the right triangle QCB that I copied from the original drawing. In this right triangle QCB, QB square equals to QC square plus BC square. So QB square equals to QC square. QC is X, therefore QC square is X square, plus B square, BC square. BC is X, therefore BC square is X square. So in total, QB square equals to X square plus X square, that is 2X square. Then we took out of this equation and finally found out that QB equals to the square root of 2 times X square. So QB equals to the square root of 2, and the square root of X square is X. So in total, QB equals to the square root of 2 times X. Here, QB, therefore QB of the right triangle QBC equals to the square root of 2 times X. And therefore PB equals to the square root of 2 units. Then, we found out that PA equals to AB. In the right triangle PAB, when we have the rule that in front of equal sides in the triangle there are equal angles. So those two angles that are located in front of those two equal sides must be equal to each other. So if this angle is alpha, then the other angle must be also equal to alpha. And we have the rule that the sum of the angles in any triangle is equal to 180 degrees, and especially it is true in triangle PAB. So which angles we have in triangle PAB? We have alpha plus 90 degrees. In total, they must be equal to 180 degrees according to the rules that I mentioned. Again, in the triangle PAB, 2 alpha plus 90 degrees equals to 180 degrees. We subtracted 90 degrees from the equation. And finally, we found out that 2 alpha equals to 180 degrees minus 90 degrees, it is 90 degrees. 2 alpha equals to 90 degrees, we divided this equation by 2 and finally found out that alpha equals to 45 degrees. So this is angle alpha that equals to 45 degrees, and this angle alpha also equals to 45 degrees in size. If you repeat on the same process on the right triangle BCQ, right to the conclusion that those two angles, each of them is equal to 45 degrees. Then I presented to you rule number 3, and we implemented rule number 3 in our drawing. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. So in the drawing we have the straight line AB. If we focus on the upper side of the straight line AB point Q, the sum of the angles here must be equal to 180 degrees. So which angles we have at the upper side of AB point Q? We have this angle alpha and the other angle that is beta. So in total, alpha plus beta must be equal to 180 degrees. According to this rule, rule number 3. So we can actually implement rule number 3 in our drawing. Why? Because in our drawing, if we focus on this straight line, on the upper side of this straight line AC, at point B, here the sum of the angles must be equal to 180 degrees according to rule number 3. So I copied the straight line in C with point B. In the new page, we implemented rule number 3 in the straight line in C. This is the straight line you see that I copied from the original drawing. This is point B that I copied. So the sum of the angles in the upper side of the straight line AC at point B must be equal to 180 degrees. So in angles we have the upper side of AC at point B. We have this angle that is equal to 45 degrees plus the missing angle that is x plus this angle that is 45 degrees. In total they must be equal to 180 degrees according to rule number 3. 45 degrees plus 45 degrees is 90 degrees. So in this side of the equation we have 90 degrees plus x that is equal to 180 degrees. Here we subtract 90 degrees from this equation and finally found out that the missing angle x equals to 90 degrees. So actually this is the missing angle x that's equal to 90 degrees in its size. Then I copied the right triangle PBQ in the new page and we blocked this right triangle by a circle. We have the rule that any triangle can be blocked by a circle. So actually this is the right triangle PBQ that I copied from the original drawing. And I blocked this right triangle PBQ by this circle. So in the drawing we have this is peripheral angle PBQ that is equal to 90 degrees in its size. And we have rule number 5 that relates to any peripheral angle that is equal to 90 degrees, any peripheral angle that is a right angle. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Okay, in the drawing we have a circle. Inside this circle we have the peripheral angle MAN that is equal to 90 degrees and its size it is a right angle. And therefore according to this rule number 5, this peripheral angle MAN must be subtended on the diameter of the circle. And indeed, it is very easy to see that peripheral angle MAN is subtended on MN, that is the diameter of the circle. Why MN is the diameter of the circle? Because of the fact that it passes from point O, that is the center of the circle. And we know that any peripheral angle that passes from the center of the circle must be the diameter of the circle. So in conclusion, we can say that because of the fact that peripheral angle MAN equals to 90 degrees in its size, therefore it is subtended on the diameter of the circle. We can implement rule number 5 in our drawing. Why? Because in our drawing we have peripheral angle PBQ that is equal to 90 degrees in size. Therefore, according to rule number 5, peripheral angle PBQ is subtended on the diameter of the circle. That is to say, PQ is the diameter of the circle. Again, because of the fact that peripheral angle PBQ equals to 90 degrees in size, therefore, according to rule number 5, peripheral angle PBQ is subtended on the diameter of the circle. That is to say, PQ is the diameter of the circle. So if we define the radius of this circle as R, then the diameter of PQ must be equal to 2R from one side, but from the other side, we have here line segment PQ. According to what is given as the question, PS equals to SQ. So if PS is X, then SQ must be also equal to X because they are equal to each other. So PQ in total will be equal to X plus X, that is 2X. So from one side PQ equals to 2X, from the other side PQ is the diameter of this circle, therefore it is equals to 2R. From those two equations we derived that 2R equals to 2X, we divided this equation by 2 and finally found out that R equals to X. Here X equals to R and here also X equals to R. Then I copied point S that is located on PQ from this original drawing to our new drawing here. So I copied point S exactly where it is located on PQ in the original drawing. So this is point S that I copied from the original drawing. So we just right now found out that PS is R. If PS is R, it is the radius of this circle, and SQ is also R. it is also, SQ is also R, it is the radius of this circle. So we have the radius PS that starts from point P and ends at point S. And we also the second radius QS that starts from point Q and ends at point S. That is to say, those two radii touch each other at point S. Therefore, point S must be the center of this circle. Okay, point S is the center of the circle. Again, point S is the center of the circle because the two radii touch each other at point S. Okay. So point S, we join points S and B together by straight line. Point S is the center of the circle, point P is the point of the circle itself, therefore SB is the radius of the circle that is equal to R. In conclusion, we found out that PS equals to HQ equals to SB, they are all the radii of this circle, therefore they are equal to each other. In the original drawing, we join points S and B together by a straight line. SB is the radius of the circle, so SB equals to SQ equals to SP. Okay? Then we did the construction. I copied this big quarter circle to a new page, and then we completed this quarter circle to a circle. This is the quarter circle that I copied from the original drawing. We have already found out that SQ equals to SB. They are both the radii of the previous circle, therefore they are equal to each other. And this is again a right angle, because this is a quarter circle, therefore this is a right angle. Then I completed this quarter circle to a circle. And then I presented to you all number 13 and we implemented all number 13 in our drawing. According to all number 13, a certain angle is twice as large as the peripheral angle subtended on the same arc. So in the drawing we have this circle, inside this circle we have peripheral angle ACB. This peripheral angle ACB equals to theta in its size, and it is subtended on RKB. In addition, in this drawing we have central angle AOB. This is central angle AOB that is subtended on the same arc RKB. Therefore, whenever you have a central angle that is subtended on the same arc as the peripheral angle, then the central angle will be twice as large as the peripheral angle that is subtended on the same arc. Here, peripheral angle ACB equals to theta, therefore the central angle AOB that is subtended on the same arc RKB is equals to theta. We can actually implement all number 13 in our drawing. Why? Because in our drawing we have, this is peripheral angle QSB. Peripheral angle QSB is subtended on RQB. But we have also central angle QCB. This central angle QCB, this is the central angle QCB that is subtended on the same arc RQB. Therefore, the size of this central angle QCB must be twice as large as the central angle QSB that is subtended on the same arc RQB. Now we have to find out what is the size of the central angle QCB, what is the size of this angle. In order to find out the size of this angle, I presented to you rule number 6. According to rule number 6, the sum of the angles around the point will always end up to 360 degrees. So in the drawing, we have here point A. According to this rule number 6, the sum of the angles around point A must be equal to 360 degrees. In order to prove that this rule is true, I draw here a straight line that passes from point A. So now we can implement here rule number 3. According to rule number 3, the sum of the angles on one side of a straight line is equal to 180 degrees. That is to say, the sum of the angles on the upper side of this straight line at point A equals to 180 degrees. Likewise, the sum of the angles in the lower side of this rectangle at point A must be also equal to 180 degrees according to the sum rule, or number 3. So in total, the sum of the angles in the upper side at point A is 180 degrees, plus the sum of the angles in the lower side of this rectangle at point A, it is also 180 degrees. So in total, the sum of the angles around point A is 180 degrees plus 180 degrees, that is 360 degrees. Exactly according to this rule, that the sum of the angles around point A is equal to 360 degrees. We can implement rule number 6 in our drawing, because in our drawing, if you focus at this point C, according to rule number 6, the sum of the angles around point C must be equal to 360 degrees. So which angles we have around point C, we have this angle that is equal to 90 degrees plus the missing angle. In total it must be equal to 360 degrees according to rule number 6. Therefore the missing angle must be equal to 270 degrees. Why? Because 270 degrees plus 90 degrees is 360 degrees. That is the sum of the angles around any point, and especially around point C. Therefore, the missing angle is 270 degrees. That is to say, the central angle QCB equals to 270 degrees in size. Therefore, according to rule number 13, the peripheral angle BSQ that is obtained on the same arc as the central angle QCB must be half of it in its size. And the central angle QCB is 270 degrees, therefore the peripheral angle must be equal to 270 degrees over 2, that is 135 degrees. So angle QSB equals to 135 degrees in its size. And we have only found out that QS equals to SB. They are both the radii of the period circle, therefore they are equal to each other. Therefore, triangle QSB is an isosceles triangle. And we have the rule that in front of equal sides in the triangle there are equal angles. So in front of those two equal sides we have those two angles that must be also equal to each other. So if this angle is alpha, then this angle must be also equal to alpha because they are equal to each other. And we also know that the sum of the angles in any triangle, and especially in the associated triangle QSB, must be equal to 180 degrees. So which angles we have in the associated triangle QSB? We have this angle alpha plus the other angle that is alpha. Alpha plus alpha, that is 2 alpha plus 135 degrees equals to 180 degrees according to the rule that I mentioned. Here we subtract 135 degrees from this equation and finally found out that 2 alpha equals to 180 degrees minus 135 degrees is 45 degrees. So 2 alpha equals to 45 degrees. We divide this equation by 2 and finally found out that alpha equals to 45 over 2 degrees. That is to say, this is angle alpha, this is equals to 45 over 2 degrees. And this is also angle alpha, this is equals to 45 over 2 degrees. Okay, then I copied the right angle PBQ in the new page. We analyze this right angle, triangle PBQ. Side PB of triangle PBQ is square root of 2. Side BQ is square root of 2 times x. And this is angle alpha, that is 45 over 2 degrees. I repeat again. This is the right angle PBQ that I copied from the original drawing. PB equals to the square root of 2, BQ equals to the square root of 2 times x, and this angle equals to alpha, that is 45 over 2 degrees. In the right triangle PBQ, times 45 over 2 degrees equals to PB over BQ. Times 45 degrees over times 45 over 2 degrees equals to PB over BQ. PB is square root of 2, BQ is square root of 2 times x. We have square root of 2 in the numerator, square root of 2 in the denominator, so square root of 2 will get cancelled, and we left only 1 over x. In conclusion, found out that times 45 over 2 degrees equals to 1 over x. Here, according to equation number 1, times 45 over 2 degrees equals to 1 over x. But we also have the trigonometric identity that tangent 2 theta equals to 2 tangent theta over 1 minus tangent square theta. We define theta as 45 over 2 degrees, and therefore 2 theta is equals to 45 degrees. Then we substitute theta in this trigonometric identity by 45 over 2 degrees, and we substitute 2 theta by 45 degrees. So here in this trigonometric identity, tangents 2 theta. And 2 theta is 45 degrees, and it equals to 2 times tangent theta. So it is 2 times tangent theta, and theta is 45 over 2 degrees. over 1 minus tangent square theta. And theta is 45 over 2 degrees according to our definition. So in conclusion, according to equation number 2, we found out that tangent 45 degrees equals to 2 times tangent 45 over 2 degrees over 1 minus tangent square of 45 over 2 degrees. Then we defined tangent 45 over 2 degrees as t, and we substitute tangent 45 over 2 degrees in equation number 2 by t. And according to equation number 2, this is equation number 2, this is equation number 2, tangent 45 degrees is 1, and it is equals to 2 times tangent 45 over 2 degrees. So it is 2 times, and tangent 45 over 2 degrees is t. So we substitute by t. So in total, the numerator here we have 2t over 1 minus tangent square 45 over 2 degrees. If tangent 45 over 2 degrees is t, then tangent square 45 over 2 degrees will be equal to t square. So in total, in the denominator here we have 1 minus t square. 1 minus t square, so we already found out that 1 equals to 2t over 1 minus t square. We multiply this equation number 2 by 1 minus t square, and finally found out that 1 minus t square equals to 2t. Then we added to this equation number 2t square, and we found out that t square plus 2t equals t square plus 2t equals to 1. Then we subtracted 1 from this equation number 2, and finally found out that t square plus 2t minus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, t squared plus 2t minus 1 equals to 0. The variable that we are looking for is t, therefore x equals to t, the coefficient a equals to 1, the coefficient b equals to 2, and the coefficient c equals to minus 1. Then we put the data inside the formula for x and found out the values of t because x equals to t. X equals to t, therefore we substitute x by t, so t equals to minus b. B is 2, therefore minus b is minus 2, plus minus square root of b squared. B is 2, therefore b squared is 2 squared, it is 4, minus 4 times a is 1, and c is minus 1, over 2a. A is 1, so it is 2 times 1. So inside the root we have minus 4 times minus 1 is plus 4, and 4 plus 4 is 8. So in total, inside the root we left only with 8. That is to say, we actually found out that t equals to minus 2 plus minus square root of 8 over 2. So t equals to minus 2 plus minus 8. 8 is 4 times 2, therefore we substitute 8 by 4 times 2 over 2. So t equals to minus 2 plus minus, the square root of 4 is 2, so inside the root we left only with 2, divided by 2. So 2 equals to minus 2 plus minus 2 times square root of 2 over 2. So t equals to minus 2 over 2 is minus 1, plus minus 2 over 2 is 1. So this expression in total equals to the square root of 2. In conclusion, found out that t equals to minus 1 plus minus square root of 2. So here we have two solutions that are possible for t. The first solution for t is that t equals to minus 1 minus square root of 2. And the second solution for t is that t equals to minus 1 plus square root of 2. So according to the first solution for t equals to minus 1 minus square root of 2. Minus 1 minus square root of 2 is a negative number, that is to say t is a negative number from one side, but from the other side, according to our definition, t equals to tangent 45 over 2 degrees, that is a positive number. So t is a positive number. So t cannot be simultaneously a negative number and a positive number, so we arrive to a contradiction. Therefore, this solution is an incorrect solution, so we cancel this solution and we have to live with the second solution that is possible for t, that t equals to minus 1 plus square root of 2. T equals to square root of 2 minus 1. We change the order from one side, but from the other side t equals to 45 over 2 degrees, according to our definition. So t equals to times 45 over 2 degrees, and t also equals to the square root of 2 minus 1. So in total, times 45 over 2 degrees equals to the square root of 2 minus 1. This equation means that t equals to t. This is according to equation number 2, while according to equation number 1, we have already found out that times 45 over 2 degrees equals to 1 over x. Here in equation number 5, we actually found out that tangent 45 over 2 degrees equals to 1 over x. So we have two equations for the value of tangent 45 over 2 degrees. Therefore, we created equation number 3 that states that tangent 45 over 2 degrees according to equation number 1 must be equal to tangent 45 over 2 degrees according to equation number 2. Tangent 45 over 2 degrees according to equation number 1 is 1 over x, and it must be equal to tangent 45 over 2 degrees according to equation number 2, that is square root of 2 minus 1. So according to equation number 3, we found out that 1 over x equals to the square root of 2 minus 1. Here we multiply this equation number 3 by x, and finally we found out that 1 equals to the square root of 2 minus 1 times x. Here we divided this equation number 3 by square root of 2 minus 1, and finally found out that x equals to 1 over square root of 2 minus 1. So x equals to 1 over square root of 2 minus 1. Then we focus on this side of the equation, and we multiply this side of the equation by square root of 2 plus 1, and then we divide it by square root of 2 plus 1. Square root of 2 plus 1 over square root of 2 plus 1 is 1. And it is allowable to multiply anything by 1. Don't change the value of the expression when you multiply it by 1. So therefore this operation is allowable. So in the numerator we have square root of 2 plus 1. In the denominator we have square root of 2 minus 1 times square root of 2 plus 1. This expression equals, according to the following algebraic identity, that a minus b times a plus b equals to a squared minus b squared. This expression will be equal to the square root of 2 squared, that is 2, minus the square root of 1 squared, that is 1. So in total, this expression equals to 2 minus 1. 2 minus 1, that is 1. So this expression in total equals to 1. So actually found out that x equals to the square root of 2 plus 1 over 2 minus 1. That is to say, x equals to the square root of 2 plus 1 over 1. 2 minus 1 is 1. So x equals to the square root of 2 plus 1 over 1. That is to say, x equals to the square root of 2 plus 1. So x equals to either square root of 2 plus 1 units in itself, or in terms of numbers, x equals to 2.414 units. I repeat again, the length of this line segment BC that is equal to x, it is equals to either square root of 2 plus 1 units, or in terms of numbers, BC that is equal to x, it is equals to 2.414 units. Okay, thank you very much.